Hello everyone. In this video we are going to explain refraction of light. Even we will discuss the refraction through the spherical lenses, convex lens and concave lens. So let's start the refraction of light. Okay. What do you mean by refraction of light? When we talk about refraction of light, the phenomenon of or the process of bending of light ray when it passes from one medium to another medium is called as refraction of light. So before understanding the refraction of light, we should understand two types of medium are there, transparent medium. One is rarer medium, okay, and another is denser medium. So what do you mean by rarer medium? A medium in which a speed of light is more. When the speed of light is more, it is a rarer medium. When the speed of light is less, okay, it is called as denser medium. Yes or no? Generally the speed of light in vacuum is 3 into 10 to the power 8 meter per second. Yes or no? So whenever light travels in the rarer medium, speed of light is generally more. When it travels in the denser medium, the speed of light generally decreases. Okay. So let's see, when light enters from one medium to another medium, the direction of propagation of light in the second medium changes. For example, this is a air. Let's say this is a rarer medium, and let's say this is a glass. Glass is comparatively a denser medium. So when ray of light is passing from air to glass, what is happening? Okay, it is bending towards the normal. Okay, this is a normal. Normal is a perpendicular, which is drawn at this point. So light is bending towards the normal. This phenomenon of bending of light ray when it passes from one medium to another medium is called as refraction of light. See, the angle made by incident ray with the normal is called as what? Angle of incidence. Okay, angle of incidence. Whereas angle made by refracted ray and the normal, okay, this is the normal, this is called as angle of refraction. So this is incident ray, this is refracted ray. Is it clear? Next. Okay, we have two laws of refraction. Okay, first law is what? The incident ray, the refracted ray, okay, and the normal all lie on the same plane at the point of incidence. See, here this is the incident ray, this is the refracted ray, and the normal all lie in the same plane. And second law is there, which is also called as Snell's law. Okay, what is this law? The ratio of sine of angle of incidence to the sine of angle of refraction is constant. Okay, sine I by sine R is a constant. This constant is also called as refractive index, represented as mu. Okay, so this law is also called as Snell's law. Sine of angle of incidence to the sine of angle of refraction is a constant. Sine I by sine R is a constant. Is it clear? Next, when we talk about refractive index of medium 2 with respect to medium 1, this is air, this is glass. So I want to know the refractive index of medium 2 with respect to 1. So we are writing like this: refractive index of medium 2 with respect to 1, or we are writing refractive index of medium 2 with respect to 1. It is nothing but sine I1 by sine I2. This is I1, let's say this is I2. Angle I2 is nothing but angle R. Yes or no? So that is also one of the formula is there to find okay. Let's see. Absolute refractive index, okay, mu is nothing but velocity of light in the vacuum to the velocity of light in medium. There are two types of refractive index. One is absolute refractive index, other is relative refractive index. We will see in the next slides. Okay, refractive index relation with the speed. This is absolute refractive index. Speed of light in vacuum to the speed of light in medium. C by V is called as what? Absolute refractive index. Okay. And another is a relative refractive index. So it is refractive index of medium 2 with respect to medium 1. Okay, is nothing but velocity of light in medium 1 by velocity of light in medium 2. So we can write a refractive index of medium 2 with respect to 1 is nothing but a velocity of light in medium 1 by velocity of light in medium 2. Okay, refractive index has no unit. Why? Because it is the ratio of two same quantity. So very important. Okay, it has no unit. It has no unit. Is it clear? Let's take one question. They have given the velocity of light in glass. Okay, let's say if it is a 2 into 10 to the power 8 meter per second. So what is the refractive index of glass? Question is there. How we are going to solve? We know the formula of absolute refractive index is nothing but the velocity of light in vacuum to the velocity of light in medium, that is glass. So C, you should remember, C is nothing but 3 into 10 to the power 8 meter per second. Yes or no? Whereas velocity of light in glass is how much? 2 into 10 to the power 8 meter per second. Yes or no? So if this get cancelled, okay, 3 by 2. 3 by 2 is nothing but 1.5. Is it clear? So questions may be asked based on this. Okay, there are some definitions you can go through. Okay, just now I explain. Okay. Now let's see. We talk about the lenses. Okay, when we talk about lens, when two spherical or plane refracting surfaces are joined, they form lens. So you can see this is a convex lens, this is a convex lens, okay, and this is a concave lens. What is a convex lens? A lens which is thick in the center and thin at the edges. You can see this is a convex lens. It is thick at the center or middle and thin at the edges. Whereas when we talk about the concave lens, the lens which is thin at the center and thick at the edges is called as concave lens. Generally what happens, okay, when a ray of light is parallel to the principal axis, after refraction it will meet at a point. The light ray converges from a convex lens. Okay, so it is also called as converging lens. Converging lens. In case of concave lens, it is called as diverging lens. Why? Because if a ray of light is parallel to the principal axis, after refraction it will diverge. Okay, it will appear to pass to one point. Okay, that's why it is called as diverging lens. Okay, you can see convex lens definition: when parallel beam of light after refraction of rays meet at a fixed point on the principal axis, that is convex lens. Okay, double convex lens is there in the syllabus. Okay, concave lens, when parallel beam of light after refraction through it, they come from a fixed point of principal axis, that is concave lens. Okay, just now I discussed double concave lens is there in the syllabus. Yes or no? Next, you should know some terms are there related to the lens. Okay, so if you see clearly that a convex lens, you see this is a convex lens. Yes or no? So this is a part of what? Another one sphere. Yes or no? This is a, and this part is nothing but it is a part of this sphere. Correct na? So this is a spherical surface. Actually this is also a spherical surface. So this is the first spherical surface, this is the second spherical surface. The geometrical center of the lens, this is called as optical center. See, for this sphere, okay, this is the center of curvature, center. Okay, for this sphere, this is the center, that is C2. So C1 is nothing but a center of curvature for this part, and C2 is nothing but center of curvature for this part. Okay, the line joining the center of curvature of two spherical part is called as what? A principal axis. Okay, this line is called as what? A principal axis. Here also see concave lens is there. This is the concave lens. Yes or no? Correct? So this is a part of this sphere. This spherical part is of this sphere. Yes or no? There is a center of this sphere. Yes or no? That is center of curvature we can represent. This is the C2. This is the center of this spherical part. Okay, the sphere. The line joining the C1, C2 is called as what? A principal axis. Okay, what is called as principal axis? You can see this is a principal axis, this line. Similarly, this line is what? A principal axis. Okay, principal axis. Here also optical center is there, the midpoint of the lens. Yes or no? Here definition you can go through. Optical center, the central point on the principal axis of the lens through incident ray of light passes. Okay, see what happens actually when a ray of light passes through optical center. This is optical center, it goes undeviated. Okay, in case of concave lens also and convex lens also. Okay, this is a convex lens, and in case of concave lens also, if a ray of light is passing through optical center, it goes undeviated. Okay, now center of curvature, the center of a sphere whose part is a spherical surface of the lens. This definition, radius of sphere. Okay, so radius of a sphere from which is a spherical surface of the lens is made. Principal axis, a straight line joining the center of curvature of the two spherical surfaces is called as principal axis. Focus, okay, point on the principal axis where the beam of light parallel to the principal axis meet after refraction. Try to understand what happens if it is a convex lens. If a ray of light is parallel to the principal axis, after refraction it will pass through one point, that is called as focus or principal focus. Okay, and the distance from O to F is called as focal length. The distance of the principal focus from optical center of the spherical lens. In case of concave lens also, you see, if a ray of light is parallel to the principal axis, after refraction it will appear to pass through one point. That is point is called as what? Focus. This is the optical center. The distance between O and F is called as focal length. Please make a note of this. Done. Now let's see the rules of image formation. Okay, we have three rules are there. Rules of image formations is very, very important. Okay, first rule, let's see, this is a convex lens and this is what for concave lens. Try to understand first rule. A ray parallel to the principal axis after refraction passes through the focus or appear to diverge from focus. See, this is a convex lens. If a ray of light is parallel to the principal axis, this is the principal axis. If a ray of light is parallel to the principal axis, after refraction it converges to focus. It always passes through focus. Here also, if a ray of light is parallel, it always passes through focus. In case of concave lens, if a ray of light is parallel to the principal axis, it will diverge. Okay, it will appear to pass through focus. Is it clear? Next, rule 2. A ray through the optical center P passes undeviated. If any ray of light is there which is passing through optical center, it goes undeviated. As I told also before, concave lens also, if a ray of light is passing, it goes undeviated. Third rule, a ray passing through the focus become parallel to the axis after refraction. Okay, this rule you see. Okay, if a ray of light is passing through focus, after refraction it become parallel. Here also, if a ray of light is directed towards focus, yes or no, so it, after refraction become parallel. Okay, you can draw like this also. This is the focus, this is the focus. If a ray of light is passing through focus, after refraction it become parallel. In case of concave lens, okay, this is the focus. If a ray of light is directed towards focus, so after refraction it become parallel. It become parallel. Okay, once again you see. If a ray of light is directed towards focus, this is the directed, so it become parallel. Yes or no? Now we will see the image formation by convex lens first. We will keep the object at different places and we will see where is the image form. Where is the image form? The first case. Okay, let's see. Object is between infinity and focus. Okay, here you should remember two things. Okay, if it is a convex lens or concave lens, okay, this side focus is there f1 and center of curvature 2f1. This side we are writing f2 and this side is 2f2. 2f1 is nothing but center of curvature of this spherical part. 2f2 is what? Center of curvature of this spherical part. Yes or no? So where is the object first? Between infinity and 2f. Okay, so beyond 2f1 we can say. So one light you take parallel, after refraction it passes through the focus according to the rule. Second, you pass through optical center, it goes undeviated. Yes or no? So they are meeting between f2 and 2f2, you can see. So here in this case, image is between f2 and 2f2. The image is real, inverted and diminished. Okay. Next, when the object is at 2f1, okay, one light you take parallel. Okay, after refraction it passes through the focus. Second, you pass through optical center, it goes undeviated. Yes or no? So you see this light ray and this light ray is meeting exactly at 2f2. So image is at 2f2. How is the image? Real, inverted and same size. Okay. Third case, when the object is between f1 and 2f1. This is f1 and this is 2f1. Okay na? So one light ray you take parallel, it will pass through focus. Second, you pass through optical center, it goes undeviated. So you can see this light ray and this light ray is meeting beyond 2f2, where they are meeting beyond 2f2. Okay, so the image is what? Beyond 2f2, real, inverted and magnified. Okay, so this is f2 and 2f2. Image is beyond 2f2, real, inverted and magnified. Is it clear? You can see clearly this light ray and this light ray is meeting after 2f2. So this is the third case. Next, when the object is at focus, okay, this is a f1 we can say. Object is at f1. One light ray you take parallel, after refraction it passes through F2, yes or no, according to the rule. Second, you pass through optical center, so it goes undeviated. You can see this light ray and this light ray will meet somewhere at infinity. So image will be also formed at infinity. Image will be real, inverted and highly magnified. Okay. Next, object is between F1 and optical center. Okay, this is optical center. So here is the object, AB is the object. One light ray you take parallel, it will pass through focus, that is F2. Second, you pass through O, it goes undeviated. Now see, this light ray and this light ray will not meet, yes or no, because they are diverging. So bring it backward. Okay, so it will appear to meet here. So A dash, B dash, image is formed. A dash, B dash, image is formed. In this case only, image is between 2F1, okay, and F1. Okay, and it is virtual and erect image. One more case is there when the object is at infinity. Okay, when the object is at infinity, in case of convex lens, the light ray will come parallelly. So after refraction, it will meet through focus only. Yes or no, it will pass through focus only. So image will be formed at focus. It will be real, inverted and point size or highly diminished, we can say. Where is the image? Image at focus. What is the nature? Real, inverted and point size. Yes or no, this is the object at infinity. Object at infinity. Very, very important. Okay, now we'll see the image formation by concave lens. Okay, concave lens is also called as divergent lens. So first one, we'll take the object at infinity. Let's see, this is the object at infinity. Object at infinity. As I told you, when the light is coming from the infinite objects, it will come parallelly. So according to the law, it will diverge. It will appear to pass through focus, yes or no. This light ray, you can see it is appeared to pass through focus. Similarly, this light ray, okay, after refraction it will appear to pass through focus, yes or no. So they will appear to meet at focus. So where is the image? At focus. Image where? At focus. Okay, and how is the image? It is virtual and erect and point size. Virtual, erect and point size. One more you can keep second case, when the object is between infinity, okay, or between F1 and 2F1, you can take, no problem. One light ray you take parallel, it will appear to pass through focus, yes or no, after refraction. Second, you pass through, it goes undeviated. Now see, this light ray and this light ray will appear to meet here, yes or no. So A dash, B dash, image is formed for the object AB. Image is what? Virtual, erect and diminished. Is it clear? So there are two cases of concave lenses. Okay. Now we talk about a lens formula. Lens formula is generally relationship between U, that is object distance, okay, relationship between the U, which is object distance, V, which is the image distance, and focal length. This is the formula actually. 1 by V minus 1 by U is equal to 1 by F. Okay, F is the focal length, V is the image distance, U is the object distance. Okay. So we will use the sign convention to solve the numerical. Okay. Here remember one thing, okay, for lens, how we are using the sign convention. All the distances are measured from the optical center. Okay, distances to the right of the optical center is taken as positive, left is taken as negative, height above the principal axis is taken as positive, and below the principal axis is taken as negative. Is it clear? We have another formula, magnification of lens. Magnification of lens is nothing but the ratio of height of image to the height of object, I by O, or we can say height of image HI by height of object, H0. Okay, it is also related with the V and U. So magnification is nothing but plus V by U, that is image distance by object distance. Remember one thing, if magnification is less than 1, image is diminished. Magnification is greater than 1, it means size of image is more than the size of object. So we can say image is enlarged, and magnification is equal to 1, means height of image and height of object both are same. Yes or no? So three things you should remember. Okay, we can solve the numericals based on this lens formula and magnification of lens. Now we have a power of lens. When we talk about the power of lens, okay, the degree of convergence or divergence of a light rays achieved by the lens is called as power. Okay, mathematically power of a lens is what? Reciprocal of focal length. Focal length should be in meter. Okay, for example, say if the focal length of the lens is 100 centimeter, okay, that is equal to 1 meter. What is the power? 1 by f. It should be in meter only, so it is 1 by 1. It is 1 diopter. A SI unit of power is what? A diopter. Okay, this is diopter. We are representing as capital D. So shorter the focal length of the lens, the more it converges or diverges. Okay, remember one thing, if it is a convex lens, so as you know that if a ray of light is parallel to the principal axis, after refraction, it will pass through focus, yes or no? Correct or not? So this focal length is on the right hand side. So focal length of this convex lens is positive. So power will be also positive. Yes or no? So here convex lens, focal length is positive. So power is also positive. Nature is converging. Now when we talk about the concave lens, as you know that if a ray of light is parallel to the principal axis, after refraction it will diverge, yes or no? So this is the focus. So focal length is on the left hand side. So focal length is what? Concave lens negative. So power is also negative. The nature is diverging. Okay, concave mirror. Okay, focal length is negative, power is positive. So converging nature is there. Convex mirror, focal length is positive. Okay, power is negative, diverging nature is there. Yes or no? So let's try one question. If the focal length of a convex lens, suppose convex lens is there, focal length is given 25 centimeter. So what is the power? Okay, so try to convert the centimeter into meter first. 25 centimeter. In meter how much? 25 by 100. Yes or no? Meter. This 25 1 ja 25 4 ja 1 by 4 meter. Yes or no? Now what is the formula? Power is equal to 1 by focal length. It should be in meter. So 1 divided by 1 by 4. Yes or no? So it will go up. So it become 4 diopter. Is it clear? You have to remember one thing, that when we are applying the sign convention, okay, in case of a lens formula, okay, so sign convention is always applied in the known quantities. Okay, suppose U is given and F is given for convex lens. Okay, for convex lens, and if they ask a V, so U is generally what? Negative, because object is on the left hand side, and focal length is also positive, because focal length is on the right hand side. In case of convex lens, V may be positive as well as negative. Okay, now when we talk about a concave lens, in case of concave lens, U is given suppose and focal length is given. So what will be the sign for U? U is always negative only. Focal length of concave lens is on the left hand side, yes or no? Why? Because in case of concave lens, if a ray of light is parallel, right, so it will appear to pass through focus, yes or no? So focal length is on the left hand side. This is the focal length. So focal length is also negative. Okay, generally we are not applying the sign convention in the unknown quantities. Okay, we will automatically get. Okay, and remember one thing, power of lens, the degree of convergence or divergence of light rays achieved by the lens is known as power of lens. Okay, suppose two lenses are joined. Okay, suppose two convex lenses are joined. Let's say the power is 1 diopter and this is 2.5 diopter. So what is the effective power? P total is equal to what? P1 plus P2 you can do. So 1 plus 1 plus 2.5, that is equal to 3.5 diopter. I hope I cleared all the concepts related to the lens. If you have understood, please subscribe the channel, share with your friend. Thank you.